Okay, so this is a makeup recording for the fact that I failed to record the lecture today. Um, Today is the 17th. We're still talking about classes and interfaces and inheritance. Um, and there was no lab today. So let's go to the slides. Now, last lecture left off at this particular slide. So this is a class called accumulator, or accum rather, and it's got a single private field value named a single private field named value. This is an instance variable, not a static variable, and it's hidden because it's private. This is a constructor. You can tell it's a constructor because the name matches the class name, and there is no return type. This constructor does nothing. So we just get value initialized to 0. And actually, all values initialize to 0 by default. So this is strictly speaking unnecessary, but it's clearer if I put it here. Here is an instance method, public void inker, and all that's going to do is increment value with by 1. Now, the way white space works in Java, right, this could be new lines in here, this could be comments in here. Anything separating these two things can take as much space as I want. Likewise here, and so on. We have another method, public void twice, another instance method. It doubles the value in value. So star equal means the same thing as value equal value times 2. We have a get method on here, sometimes called an accessor. So public int get returns this private value. And then I have a public string toString method. And what this is going to do is it's going to create a string version of the contents of this class. And the way it does it is it creates empty quotes and adds a value. And the Java runtime will convert this to a string for us. Okay, the next method on here is called equals. Now this overrides a method from object. Whenever we don't explicitly extend a class, we are extending class object. And class object has public Boolean equals on it. You may recall that you are supposed to compare objects with the equals method instead of the equal equal, because with objects, the equal equal will simply compare the location in memory that the object is stored. So what we're going to do, in order to compare two accum objects, we have a problem to solve, and that is equals takes an argument of type object, and object is the wrong type, right? We want to see accum here. So what we want to do, we want to convert this object into an accum, and the way we do it is with a cast. A cast puts the class name in parentheses like this in front of the variable name, and then I can have a new declaration over here with the type I want. So this will cast the object to an accum. Now it is possible, right, that I could call this equals method with something that is not of the correct type. Like I could put a string here or a wrapper type, like a capital integer or something here. And then this cast wouldn't be correct. In that case, what will happen is your code will die with what's called a class cast exception. And that isn't something that we want to see happen. So what we do first is we check to see if the cast is safe. Oops, let me go back. If O instance of accum is true, that means that O can safely be cast to an accum. So first we ask the runtime, can I change O to an accum? And if the answer is yes, then we do it. Now that I've got an accum, what I want to do is I want to compare that the values are the same. So we want to compare that A dot value is equal to this dot value. This dot is implicit here. So I'm comparing the value of value in this instance of accum, and this is the instance field here. So that's what I'm comparing here. And if it cannot be cast to an accum, if it's not safe to cast it to an accum, then I'm going to return false from this equals method, so that an accum can't equals a string, for example. All right, now all classes should have a test on them, because if you don't test your code, It's guaranteed that it won't work. So here we have public static void main as our method. We're going to instantiate an accum object, and we're going to anchor it twice, and then we're going to twice it. So it starts out at 0. This makes it this gets called, and it gets incremented by 1. This gets called, incremented by 1 again. Twice gets called, and it gets doubled. So it's 4 now. So so when I print this out, I get system.out.println m equal 4 is what I see on the screen. And then the next thing is an assert statement. So we have assert m dot equals new accum. Now what's going to happen here is we've already established that this m is 4 and the new accum is going to be 0. So this code here is this test here is going to fail. And what will happen is assert if asserts are enabled, the code will fail here with an assertion error. Assert is a very important debugging tool. The way you use it is you say assert, and then you say something that you believe to be true about your program, right? And when you run with asserts enabled, it will tell you if the thing you think is true actually is. If this were to be true, and I ran with assertions enabled, this code would do nothing. It would just proceed as usual. So let's take a look at how this works. So I've got the class preloaded here in my command line tool. And what I'm going to do first is I'm going to compile it with the Java compiler. Okay, it compiles just fine. And if I run it, it also runs just fine. But now I'm going to run it with assertions enabled. And you see that I get an error on line 19. And so that's how that works. Asserts are important. We will use them frequently in this course. We will probably use them in every lab. They'll be part of your testers and so on. It's generally a good idea to use them in your coding. Okay, that's enough about accum. So just things to make sure you notice on the previous slide, the instance of checks and the cast. And you should note that if a class B is a subclass of A, then one can assign AA equal new B. So, and the compiler can check that, but not the other way around. So this is why we have things like instance of and cast. So now let's take a look at class accum2. Accum2 is going to extend accum1. And that means that it's automatically going to get this anchor, twice, and get method. Those are all just going to come along for the ride, as will the equals method. All these things that I've already coded here will come along for the ride and be part of accum2 without me having to specify them. They just come in from extends accum. Okay, so accum2 is going to have 2 constructors. It's going to have an empty constructor, and it's going to take another kind of constructor, which takes something of type accum. And inside that method, we're going to have a while. And when that while is called, we're going to call get on the current object. And as long as that's less than m.get, as long as it's less than the value here, I'm going to call anchor. And the net effect of this is that when when this constructor finishes running, the object will have the same value inside it as the value I passed here. So now if we look at this code, we have a main method. We're going to instantiate class accum2, and we're going to assign it in class accum, just accum. Now, the reason this works, right, is because when I extend a class, I'm sort of making things more specific. So if you want to think about it in an analogy, you can think of accum as being like a cat, right? And accum2 as being a Siamese. So you can say that a Siamese is a cat, but you can't say it the other way around. You can't say a cat is a Siamese. A cat might be a Siamese, or it might be an Abyssinian, or whatever. Okay, so you can always assign data of a subclass to a variable that has the type of a superclass. All right. Anyway, this logic is the same as the previous slide, m.anchor, m.anchor, m.twice. This raises m to 4, and so m will print 4. But here, the assertion is going to be true because instead of saying new accum2 with nothing inside here, I'm putting an m, and that m is going to increment until I get there. So this shows you a statement where the assertion is true. And let me see. I didn't preload this one, but let me just make sure I've copied it. I'm going to copy that into accum2.java, paste. That runs, and now I'm going to run with assertions. And look, the assertions work this time. Okay. All right. Now, the next thing I want to talk to you about are interfaces. Interfaces are kind of like classes, but they have no method bodies. An interface is kind of like a blueprint. It's kind of a specification of the kind of things you want a class to be able to do. So in this case, what I have is public interface array printer I. So the name I picked here, I put a capital I at the end just to emphasize the fact that this is an interface. I don't have to do that. The next thing I want you to note is everything in here is implicitly public. So I said void println, but this is really public void println because it's an interface. Now, an array printer I means that whatever the thing is, that whatever the type is I want to hold in something of type array printer I, it has to have a method that matches this signature, something that returns a void, is named println, and takes an argument of type int array, and that's it. All right, so it has to have that. And the way I'm going to write all labs in this course, the way I'm going to deliver all labs to you is I'm going to give you an interface with some documentation. And I'm going to ask you to write a class that implements it. And then I'm going to have a tester that's going to test that your interface works as expected. Okay, so here is an example implementation of array printer I. I'm calling this array printer A. The override tag is optional, and it just says that I'm overriding a method in array printer I. And override is checking to make sure like I've spelled things correctly and I have the types correctly. It's checking to see that there really is something of type public void println int array on the superclass, in this case, the interface. The next thing I want you to take note of is the enhanced for loop on this line here. So an enhanced for loop, instead of having two semicolons, has a single colon. And the notion is that if I have an array or an array list in this position where X is, I can have a variable that is of the same type as an element of that array or array list. And what this will do is it will iterate through each element of the array list. So this is kind of the equivalent of for int I equals 0, I less than x dot length, I plus plus, and then on the next line, n equal x square bracket I. So it's the equivalent of some longer code. It's a shorthand. It's, as I say, it's called the enhanced for loop. So what this is going to do is it's going to print out every element of this array, one value on each line. The next class I'm going to look at is, I'm going to talk to you about is array printer B. This is another example of an implementation of printer I. And again, I'm overriding public void println. This time, however, what I'm doing is first printing, not printlning, right? It's just all on the same line. I'm going to print a curly bracket. And then I'm going to have a more traditional for loop here. And only if I is greater than 0, I'm going to print a comma and then a space, because what I want to do is put a comma and a space between each value. And then I'm going to print the value. And finally, I'm going to do a println, so that's got a new line in it because of the ln. And I'm going to put a closed curly. So this is going to put a closed curly, and then all the values separated by commas, and then a closed curly. And that's how array printer B is going to work. Okay, so let's put it together. We're going to make a class called array printer, and it's going to have a public static void main. And we're going to instantiate an array of integers. And the syntax for that is to say new int square bracket curly brace, and then list the values. and then do a closed curly brace and a semicolon. We might recognize these as Fibonacci numbers. Okay, so the next thing I'm going to do is I'm going to take an object, I'm going to take a variable of type array printer I, right? And I'm going to instantiate an array printer A and assign it to that variable. Now, I cannot instantiate an array printer I because you cannot instantiate interfaces. Interfaces are impossible to instantiate because their method bodies are empty. The compiler and the runtime don't know what to do with that. So you're just not allowed to create one. You are, however, allowed to make a variable of type array printer I and assign something to it that has those implementations. Okay, so I instantiate array printer A, assign it to printer, and then I call printer.println with ARR, and that's going to print one value per line. So it's going to be 1, 1, 2, 3, 4, etc. Okay. Then I'm going to reassign printer with new array printer B. Now, in both these cases, this line and this line, I'm assigning a subclass to a superclass type. So that's okay. The compiler doesn't complain about that, and I don't have to cast. And now I'm calling this same variable with .println, but now it's doing something differently. It's doing something different because printer is storing a different type of value. And this way that I can change the behavior of println with a different implementation like this is called polymorphism. Okay. And here is the output that I get from all that. So this is how printer A prints out the array, and this is how printer B prints out the array. Beautiful, right? Okay, so I'm just going to point out again that all objects that don't explicitly extend something are extending class object. And class object has an empty constructor, and it has an equals method that just calls equal equal, which is, kind of useless. And it's got a toString method that often just prints the location of the object in memory, also kind of useless. And it's got a hash code method, and you won't find out what that means until later in the course. I'm just letting you know that it's there. And it has some other methods that we don't care about in this course. Two things I want to sort of bring to your attention are toString and println, because sometimes students get these two things confused. So toString is just going to create a data object in memory. It's just going to format something into a string and keep that string in memory, whereas println is going to take a string and make it appear on the console. So the notion is that I could put a println inside a toString, and if I did that, then what would happen is when the toString method got called, something would print on the console. The toString method can be called implicitly by the Java by Java if it needs if say you want to append an object to a string. If you do that, Java will implicitly call the toString method on the object. So let's take a look at how some of these things might work. I have an example of sort of an extended example of using a string builder. So I'm creating public class Martian extends object. Now I didn't have to say extends object. That's implicit, right? If I left that off, everything would work the same way. Now I'm going to put a string name, an int age, and int array coord location. And then I'm going to put a constructor, public Martian, string int, blah, blah, blah. And then I set all those values inside the constructor. Now in my toString method, what I'm going to do is I'm going to create a string builder. I'm going to append a string, and then I'm going to append a name and another string and the age, and then the two coordinate locations. Then the two coordinate locations separated by a space. And so let's take a look at how this code. Hold on. Let's take a look at how this code behaves. We'll copy it again to our command line. Okay. So now that I do this, I see there's a bug here. I meant to put age, and then I meant to put all right. So let's redo that. Ah, it has bad quotes in it. Uh, So you see, it uses some funny special quote character instead of the normal one that Java is expecting. And so I'll fix that. And now I'll run the code. And it says name Steve, age 61, location 55,186, right? So that's how that works. And uh, and that's as far as we got in class today. So I hope that was helpful, and thank you for your attention.